Okay, so this question here, it's got a lot going on. They give me f, this exponential function. They ask me for the first four non-zero terms in the general term. For the series expansion about x equals 0, it's a Taylor series. They, in part B, asked me to find the interval of convergence, show all my work. And then they have this weird spot where it's like, give the sum of the first four non-zero terms, what are they? And then show that weird g minus f, or f minus g, absolute value is less than 0.02. To me, when I read that at first, this looks a lot like alternating series error bound, and I sort of hope that alternating series show up as I go through. This is very much like an AP type problem, part of what they would ask on the FRQ section. So to start, I just need to know the series for e to the x. So for part A, e to the x is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus ... x to the n over n factorial. So the reason why I wrote it like that, well, one, you need to know that. It's the easiest of the series to know because it's just like the powers go up and the factorials go up and they stay in the bottom. Everything's positive, nothing complicated. So the reason why I wrote this is because they asked me for the first four non-zero terms and the general term. So I did that for e to the x. Now what I can do is change all of the x's that I have to negative 2x squared. This is e to anything would be this. So I'm just going to think of my anything as being that right there. And how do I do that algebraically? I substitute in negative 2x squared everywhere that I have an x here. So it's not crazy at first. I get e to the negative 2x squared is the 1 stays there. This x there changes to that. So I get minus 2x squared plus up here I've got an x squared. So I need to change that x to this. So what's that look like? Something squared. What's the something? It's my negative 2x squared like that. Over 2 factorial. Plus, open parentheses, negative 2x squared cubed over 3 factorial plus trying to leave enough space, plus negative 2x squared to the nth over n factorial. So that is all of part A. I've got the first four non-zero terms and the nth term. You could simplify this if you want. This 2 would get squared to become a 4. The negative gets squared out. It divides by this. So this would also be, I guess I'll write it, this term could be replaced by a positive 2x to the 4th. Why is it to the 4th? Because I would square my x squared, and that's how exponents work. Then this guy would be minus, I would have 2 cubed, which is 8, divided by 6. So that gives me 4 over 3, x to the 6th, and then this term here doesn't change. So now I got to do part B. I am going to do the interval of convergence on this thing right here. So I will scooch, well, I'll just leave it there. So part B, L is the limit. I'm using the ratio test. Anytime they ask me for an interval or a radius of convergence, I use the ratio test. As n goes to infinity, absolute value, a sub n plus 1 over a sub n. Well, that is limit as n goes to infinity, absolute value. I get negative 2x squared to the n plus 1. And you know what I'm going to do? I'm going to recognize that this is an absolute value. So all my negatives are going to go away. So I am not going to write that negative. It's just going to be easier to cancel things now. I can do that if I write this. If I start skipping steps, then you're liable to lose points on the AP test. So over n plus 1 factorial times, I multiply by the reciprocal with n's in there, so just multiply by the reciprocal of this thing. That gives me n factorial over 2x squared to the n. You could, if you want, have simplified this a little bit, but you might wind up like simplifying something and then having to undo that simplification later. So I actually prefer to leave things in this. So for the second part here, for part B, they asked me to find the interval of convergence. Anytime I see the interval of convergence, I do the ratio test. Interval or radius of convergence. It's always the ratio test. So I need to do it on this thing right here. Move over just a little bit so we can still see it. So that's the piece that I'm going to do my interval of convergence on, where this is my AN. So let me scroll down a little bit. When I plug those pieces in, I get that it's the limit as n goes to infinity, absolute value. The first thing that I'm going to take note of is that the negative is going to go away. I've got absolute values on here, so any positives or negatives that are being multiplied, they will they'll get absolute valued out. So I can ignore that. I'll show you what I'm going to write. I'm going to write 2x squared to the n plus 1 over n plus 1 factorial. And then my next part is I'm going to flip this because that's the division of a sub n. So I get n factorial over, open parentheses, 2x squared to the n. So let me talk about a couple things that I did there. One, the negative. I didn't put it here because I've got absolute values. What notation do I have to carry to be able to do that? I got to write this first. Otherwise, the AP might knock me on continuity of thought, right? Like not plugging this in here, but plugging a different version of that in. So make sure you do this if you're going to drop those negatives early. From there, I got to figure out what cancels. So let's start with the factorials. A factorial, like 10 factorial, would be, say n was 10. I would have 11 factorial. That would be 11 times 10 times 9 times 8 times 7. Well, if n was 10, then I would get a 10 factorial here. And that'd be 10 times 9 times 8 times 7, all the way down to 1. So this is going to cancel with all the factorial pieces in this guy, except for the last one. What does that look like? This n factorial cancels everything that factorials except for the n plus 1. I leave that n plus 1 there, and that's how I do the notation for it. I just cross off the factorial and the n factorial. Same thing here. This guy is going to cancel with, well, let me talk about it. 2x squared to the n. Well, I got 2x squared to the n plus 1 more. So all of them up to n in this one are going to cancel with all those, and I'm going to be left with just that one. How do I write that? I just cross off the exponent and leave this piece here. So what's that give me? It gives me the limit as n goes to infinity, absolute value, 2x squared over n plus 1. Now, this limit's great. A lot of times when we find an interval or a radius, it takes a lot of effort to do a bunch of stuff putting in between ones. But this limit, n's going to infinity, and 2x squared is just a number. So when I let n go to infinity, I get n plus 1. I get an infinity in the bottom, which beats this and goes to 0. Now, our conditions are that we always want this to be less than 1. So I write less than 1, because 0 is always less than 1. There's no x's to change there like there are in some of these other problems. So I say, therefore, converges for all values of x. Essentially, I can make x anything, and this will win. You have to think of x as being a number. X is a number. Take a number and divide it by infinity, and the whole expression goes to 0. So this converges for all values of x. So now we're ready for part C. I got rid of some of the stuff from the previous problems. So, like I said earlier, this screams alternating series to me. If I look at this, I got 1 minus, boom, plus, boom. This one's negative, because it would be cubed, plus, and look, I got n over as an exponent, and there's a negative number in here. So this is going to alternate. Even values of n, this will be positive. Odd values of n, this will be negative. So I want to recognize first that this is alternating. And then I'm going to use alternating series error bound. So I've explained this in class, so I'm not going to go in crazy detail, but essentially what the alternating series error bound says is that if I've got a series, like, for example, 4 terms here, that the error of those terms to the infinite sum are the absolute value of the next term, right? So in this case, I've got 4 terms. So what I'm going to do is look at the 5th term, and I'm going to plug in things based on what they tell me here. So I'm going to write a sub 5 is equal to, I'm going to get, do I want to use a sub 5? I'm going to use a sub 5, even though it is the, sorry about that. I'm going to write the absolute value of a sub 5 is equal to, it's the next term, so that would actually be n equal to 4, because notice this is n equal to 0. It's going to be open parentheses, 2x, I dropped the negative because it's got absolute values, squared to the 4th over 4 factorial. Well, if I simplify that, I get 2 over 3 times x to the 8th. Now, you may say, what does that have to do with all this? Well, that gives me, this here gives me an error on all this stuff. Notice this has an x in it. I can plug in this x value of 0.6. I could plug in negative 0.6 or positive 0.6 in here, and it would give me the same value because it's got an 8th power. So what I'm going to write is that the absolute value of a sub 5, and I'm mixing some math notation here, evaluated at, well, undo, I'm going to write of plus or minus 0.6. Well, that is equal to 2 over 3, open parentheses, 0.6, added to the 8th. And if I do that with my calculator, right, I can't do that by hand. If I do that with my calculator, or I don't want to do it by hand, I get 0.011 to 3 decimals. Now, notice, they want me to show that it's less than 0.2. This becomes a ceiling on the error. So I know that my error is this or less. Well, take note, this number is clearly less than this, so I write less than 0.02, and then I just say, therefore, by alternating series error bounds, S sub 4, the 4th sum, is within 0.02 of, what do we call it up here? F of plus or minus 0.6. And we are done. I guess one thing I should say is that, they here said use all the bounds in there, right? Clearly, if I were to put a smaller number in here than 0.6, I mean a number like 0.5, 0.4, down to negative 0.6, that this number here would be smaller, and it would still be smaller than this. So this is true for any value of x between negative 0.6 and positive 0.6.